Okay, that's great. Let's look away for a second. And we've got Art. Welcome back, everybody. If everyone can hear me. I'll turn on the video for a second. How's everyone doing? Welcome back from I feel like it's been long away, even though we've been talking online. We haven't done a live thing like this in a couple weeks. Well, office hour last week, but now, now you can see me. Hi, everyone. Now we have our lectures starting again. So hopefully everyone had a good, it wasn't a break because everyone's working hard on things they're doing, but at least a change of pace. And this week's probably back to regular full schedule with all courses and lectures. Hope everything's going well for people. Today we're going to talk about documents. Right, so we'll talk about a new type of data that we haven't talked about yet, which is text language as a data. So using human language, we're going to be focusing on English for the examples I have, but it's not limited to English, obviously, although some languages are harder than others. Okay, so I should turn on the chat. Yes, we're going to finish on rest of ensemble managers. Thanks, Sophia. I was loading up my slides yesterday and looking and said, wait, we didn't finish that. So yeah, I'm going to finish talking about streaming ensemble methods. So if you have questions about Hufting Tree, and we'll talk about Mondrian, and then I'll go on to this text classification things. And if there's there are other kind of big issues or questions people have, can let me know. I guess, what other announcements do I have just for that? Okay. So, like today we'll continue the previous topic, and just a couple announcements. We have a new TA, so that's great. Mohammed Gasly. You can just call him Gasly, he says, so that's easier. There's so many Mohammeds, it's good to be able to distinguish. He's a PhD student in doing machine learning with Professor Kurai in UCE. So you've got three, I think he's a master's student, actually. Three strong machine learning students. They're all doing different types of things. So he probably has his own specialization, and you can kind of ask him for help on anything, just like everybody else. He's also going to be the TA for House 1, which helps because I was the person for House 1, so there hasn't been as many activities for them, so I apologize for those people, but I know they had their own discussions internally. I'd be curious to hear from people. Maybe later in the term I'll do a poll from everyone to see if these houses and groups were helpful. It was just kind of an idea I had to kind of encourage communication with smaller groups of people because it's such a large course. I am still going to try to at least report Kaggle results per house, but we've got to write a script to kind of pull that data out. So for assignment 2, we'll do that and have it up. Assignment 2 is still due Friday, so eager to hear how people are doing on that. Seems like there are some questions. I know the TAs have been answering a bunch of questions on that. Assignment 1, I thought people did pretty good. It was a good average. It was kind of in the mid-80s, and most people did most of the stuff pretty well. There were little finicky things. I know a few people had some bigger discussions, and we're continuing out on Piazza, but we're going to try and wrap up those discussions of assignment 1 by midweek. And then assignment 2 we do Friday. And then, yeah, so maybe this Wednesday, since there's no test or anything this week, for my office hours, I might arrange one-on-ones, so people who wanted to talk to me directly, I'll use that slot and you can kind of come in one at a time. I'll set that up, but I'll have to go through my Piazza posts. So as always, if you want to ask a specific question, post it to Piazza as a private question, and then myself or one of the TAs will answer it and get through it, and if it's you want to talk to one of us directly or talk to me, we'll arrange a time to do that, and I'll do a bunch this Wednesday. And test 1 we're still grading. The automated graded part with all the multiple choice is obviously there, And it was a bit all over the place, so I do want to look over those questions and do a bit of a review with everybody and try to figure out if there were any kind of confusions or anything, so that we can kind of adapt that better for the second test. But everyone's still grading the derivation question for the MLE and MAP, and from what I'd seen from my initial grading of it, it seemed like everybody did really well on that, so that's good. It's all my other maybe vague questions about classification with pictures that maybe wasn't clear to people, but we'll adjust as we can. Okay, let's see what people have questions about. Yeah, so for pre-processing for assignment two, we didn't really give you a lot of like details on pre-processing, so you sort of basically start doing what you think is best based on the data and the algorithm you're in. And as people say, in a decision tree, it's not as important, but it's still useful, right? So why did we have that? We had an example of that in last office hour. I'm trying to remember the example. Yeah, you're right. Like, it's not strictly necessary for each of the splits, because it can balance out the impact of the split for each feature, right? I had a good idea about why sometimes it's useful, but you're right. It's not strictly necessary. Decision trees will work without normalization. Yeah, there's some cases where it still could be useful though. Let's see if I can remember why that was. Validation accuracy only. Okay, sorry, someone else had to do about the interpretation, right? So people were getting confused about the interpretation. Yeah, so the interpreting, I think Benjamin had a post about this. Which question was that? That's CM6, right? Hopefully he had a post on Friday. But the idea was that decision trees are one of the last models that are really powerful that you can do interpretation from. And maybe we should get Shelja to give us some discussion about interpretability at some point, because she kind of specializes in that. Let me just... Okay, people have colds. So a reminder to mute yourself if you're not going to be talking. Feel free to sometimes chime in and say hello, but the chat's a better way to lead that out, and then we can kind of lead someone in. What am I looking for? There was a way to visualize. There's a print or plot method for decision trees. I just want to show you an example of it. I remember finding it last time. Yeah, plot tree. I thought this was a good way to do it. Right. So it only works for individual decision trees. This is something that maybe people were worrying about. Like if you try to do this for random forests or anything else, it's going to be very challenging, because there's completely different features for every tree. And if you do something like extremely randomized trees, then the splits don't really make any difference. They mean something, but you'd be figuring out how each different tree has its own splits, and it would still give you a story, but they wouldn't necessarily be meaningful. But if you use this plot tree method, and when I wrote the assignment, I didn't look up what method there might be, but I know in general, you've got a decision tree. This decision tree, I guess, has 2 levels. I'll debate whether they call it 2 or 3 levels. And they've split on different features, right? So they chose feature 3 here, then feature 2, and they have the scores to figure out whether they were going to, how they chose this feature in the split point. And there's some values left over, right? And so every one of these leaves has certain values that are in them, and you could plot that out. So the idea is for you, just for your decision tree, is to plot the results and analyze it and see if any of the patterns, the single decision tree, I'm sorry, you can't see my tablet anymore. This is just for the single decision tree situation. And describe what you find, right? So what we found that is that the decision tree probably won't be the best model, right? Because it's only learning a single tree, and random forests learn many decision trees, look across them, and the boosting is going to improve on parts of the data that the previous trees didn't work. So your decision tree won't necessarily have the best result, but it might have a pretty good result on some of your tests, and then you can try to interpret it, what it means, right? And in our COVID data, I don't know, we could look at, it'd be interesting to see what people get and what could be interesting patterns, because you might expect, you've got Ontario, and you've got your COVID data, but we have lat long, which ones? I guess that's long, coordinates. That's one of your features, right? So it's very possible that, when one of your leaves splits on a certain spot, and essentially this whole side of the province is on one side of your tree, and this side of the province is in another part of your tree. This is Toronto. And, that's something that would literally show up in the tree, and it might help with, the prediction. But there might be other things with age or other features. So see what the tree finds and figure out what it means, right? Because most models we're doing, you can't ask this question what the model means or what it's thinking. And it's interesting to explore that. So that's all I meant for that question. Hopefully that will help people a bit. Okay, then I have a bunch of questions. Okay, the people discussing training, testing, validation. I think there's a bunch of discussion on the discussion board, so make sure you do that properly. As Alex is pointing out, your final results are always about the test set. You can report your accuracy and your numbers on the training set as well, and on the validation set, although it's kind of less interesting because it's so small. But the numbers you report on the test set is really the gold standard, right? That's what you want. That's what you're posting, the main results in your plots. And that's what we're kind of evaluating on Kaggle, because it's only on the test data. And the Kaggle one, it's on a test data set that you've never seen, right? So that's important. Great. Solutions of test 1. Yeah, so we'll have a, well, that's a good idea. I think we did mean to do that. So once we create the version of it, the solution for the derivation question. Yeah, we'll do that. Well, I have a messy version of it. Let's see if it's presentable, and we'll send it out. But all the other ones, the other multiple choice questions and stuff, we'll discuss it, but I'm not going to release like a key because it's hard enough to come up with new questions. But we'll talk about them, or I'll create a video going through the things that people had problems with. I have to decide how to do that. Removing outliers. You should always clean your data. No, you're going to be experimenting with different numbers of trees, so that's useful. I think in COVID we said to predict all the categories, right? Whatever we said in the assignment, my idea was that you have 3 different categories, so your accuracy can be on getting the correct category for any item, right? Fatality is obviously the most important, and if you want to break it down and predict how well you're doing on fatality versus non-fatality, that's an interesting sub-sample of it. So you could come up with a binary classifier and compare to that. But the main idea is you have a 3-class problem. What's your accuracy on predicting all the classes? Yeah, great. People seem to be helping each other. Variable smoothing. Yeah, so I mean, for Gaussian variable smoothing for Gaussian naive Bayes, well, the impact is what we've asked you to evaluate. So try it out and see what it is and try to describe what you're seeing happening. But, you know, it has the same effect that smoothing usually has on things, right? You're reducing, small impacts from very small deviations and overfitting. It has a bunch of benefits, but see how it helps you in your particular problem. Yeah, so a good question of like, well, you got 100% on your training set and even your validation set, and your test set you had 90, 95%. So that's actually, pretty good. Maybe you worry if you're overfitting on your, if your training set is that you're getting 100%, then maybe your model is a bit too specific. It could be that you could have a model that kind of backs off on getting it so perfect on the training set. It might actually do better on the test set. So sometimes backing off on your model's power so that it doesn't get 100% on your training could actually help you do better on the real world test set, right? So for random forests and things, that could be use less trees or less deep trees. Right? Trees tend to overfit when they get very deep. So you could try shorter trees. That's going to reduce your training accuracy, but you might actually find your test accuracy could go up. But that's in the general way you want, right? You expect your test accuracy to be lower than your training and validation accuracy. But like I said, being 100% on anything, you should be a little suspicious. It doesn't mean it's wrong. It just means maybe you went too far because nothing is 100% in the world. Data always has its own noise and patterns. So it's usually something to be wary of. Oh, right. So there's the interpreting the learned parameters of naive Bayes. Because we were talking about what naive Bayes is learning, right? If you read about naive Bayes models online, you can find a bunch of things about this. I think in my slides I mentioned it briefly, but the main idea is you have some variables, right? And then you've got your I was worried about doing it the wrong direction. The class label that you're trying to interpret, right? And each of these has their own parameter that they're fitting for each one of them, right? And it kind of describes a ratio of like how important this feature is. Right? Yeah. Sorry. These are actually separate. Features of your data set. Sorry, I'm thinking of a different model. Right, you're saying that all the features are independent, and so you have a model that kind of adds them together, and essentially that the probability of each one having some value contributes to your class label. But how important is this feature to the label, right? And if you work out the probability of it, you have to go and look at it directly to come up with it. But essentially like an increase in each of these values by some amount means that it's essentially, you know, that much more important than some other parameter, right? So you can interpret the numbers that come out of this as kind of the relative importance of the different features. And so you can try to use that to interpret it. It's not as good as the decision tree interpretation, not as kind of rich as that, because the decision tree has all this very specific values and everything, but the naive Bayes parameters are interpretable a little bit as ratios of probabilities. So think about it that way a little bit, and then and just try to say something about it, because like we said, interpretation is not the hugest part of this course. It's most of the time you can't really interpret the parameters of the model directly, but that's one where you can do it a bit. Hopefully that helps. Yeah, we'll try to find some label for that. I remember seeing it, either it's in my slides or in one of the references I was using. It was described quite well somewhere.